in a very early universe had a phase change from neutral to ionized. Soon after the Big Bang, the universe expanded. Expansion means universe cooled down, temperature went down, colder, and then universe became neutral. Neutral means proton and electron are together,
Proton.
making hydrogen atom. Before that, it was ionized plasma. Electrons and protons are flying around. But now, because temperature is cold, they put together, they're combined together to make hydrogen atoms. In nowadays universe, it's a plasma again. It's not hydrogen atom, it's electrons and a proton again. So there was an ionization process. It's a big phase change early in the universe. And what caused this ionization is a big mystery. We know there was a phase change, but we don't know what caused it. Who did it? That was the question.
中文叫在电里。
Yes. This happened early in the universe, but we didn't know who did this. And then we found 100 black holes, supermassive black holes. By the way, each one of them is like several billion solar masses. So each one of these black holes are billion times more massive than our sun.
一个黑洞就比太阳的100万倍到
yes.
一个
Yes,
only one.
we found 100 of them, but this is very, very small number. This is an interesting discovery. So that's why we know these black holes did not do it. Did not reionize it, did not ionize the universe. This black hole did not do it. That's the scientifically important part of this discovery.
So
That's 中心吧
neutralize.
So universe was from 中心 to DNB. Years and later.
And later? Okay.
So there was a discussion, but from our result, it's clear not by black hole. So this is a big international team, not just myself. Then this is explaining what is supermassive black hole. 1 to 10 billion times more massive than our sun. So it's very massive. That's what we are looking for. And at the center of almost all galaxies, there is at least one supermassive black hole. Our Milky Way galaxy also has one supermassive black hole at the center.
Galaxy 就我们说星系吗？星系啊。
This is a cartoon, our imaginary view of supermassive black hole. And a black hole at the center is of course black because light cannot come out. But actually black hole has a huge gravity, so it accretes a lot of material around it, gas and dust. And then when they fall, these gas and dust fall into black hole, they release a huge gravitational energy, and then this region becomes very hot and then bright. So actually, black holes itself is dark, but around the black hole it's very, very bright. So that's why even they are at 13 billion light years away, we can see it. And then this is the Subaru telescope. So there's a mirror, 8-meter mirror inside here. Then this is like a 4-story building.
You have been there several times, right?
Yeah, many times, yes. To operate this telescope one night, 3 by 1 Taipei, one night. And then we have 300 nights, so it's a big project. But how we found it is, so this is a black hole, because this black hole is very, very distant. Because of something called redshift of the universe, because the universe is expanding, more distant object becomes redder. This is called redshift. So more distant one becomes more redder. And then this one is very red, you see, right? Because they are moving away from it. So one of the difficulty in finding black hole is because black hole is such tiny dots, and then there are billions of objects in a data. So it's actually very difficult to find black holes. We have 100, but compared to billion, 100 is a very small number. So there are a lot more other objects. It's not black hole.
Did you name the black hole? Give it a name or
Not really.
like
We don't. We don't. We just call it by coordinates. 1139 plus 60 something. I have good students. I have good postdocs, researchers. So this is a very good environment for me. I like in Taiwan because in Taiwan students and teachers are like friends. I like this Taiwan style very much.